See if anybody logs in. See if anybody actually logs in. Well, I actually got somebody on. Nobody left. So much for that. Ask me any questions. It's a live Q&A. If you have any questions, go in the chat. If you have any questions, just send me something in the live chat there, and it's more of a Q&A. So, I'm showing some of my Christmas gifts. Got a new stand for the cell phone, so it's got a microphone, it's got a light, it's got the tripod there. So I got that, and I also got my wife got me for Christmas the Campark Ultra 4K action camera. So that's actually what I'm using right now for the live stream. So you can see the quality of the camera is actually pretty good. So yeah, it's a really cool camera. I got to get a micro SD card for it. If you guys have any questions, I got the live chat there. You can ask me. It's kind of a Q&A, so I got some free time here. So yeah. So yeah, had a good Christmas. Hope everybody else had a good Christmas. And I'll be doing some stuff hopefully this week. I'll be working with a generator, and I think people are logging in and out. I don't know if there's a connection problem or what. But I'm a lot better than what I was. This camera makes my eyes look really weird. It makes me look like I'm like a zombie. So yeah, type anything in the chat there if you want to ask me any questions or whatever regarding my experiments. I also got from my wife, I got these magnetic rings. They're magnetically polarized rings. If I can even get it off. And they're magnetic. They actually have a north and a south pole. So your blood is magnetic. So yeah. Enter the chat. Ask me questions if you want. I only got one or two people popping in and out. If you have any questions, put it in the chat and I can answer your questions. Just kind of showing off, I got the new webcam, action cam, 4K Ultra HD. I'm actually using this for the video feed right now. So I got that for Christmas, and then I also got the tripod and the microphone so I can put the cell phone on there. My daughter's clearly on the ground. So yeah, I'll be using that. I can see it, Angela. Daughter's trying to stay out of the picture. So yeah, I had a good Christmas. Hope everybody else had a good Christmas. If you have any questions or whatever, send me in the chat there on the side. Enter the live chat. Questions about my experiments, what I've done, what I haven't done, anything. Yeah, just send me some questions here, and I can help you guys out if you have any questions. I'm right here right now. It's Q&A, so you can do what you want. Let's see if you guys can hear me. I don't know if I have an audio problem. Can you type in "can't hear me"? I don't know if I got an audio issue here. I'm going to type on Not sure if I got audio going here. You guys can hear me, or? I'm here if you guys want any questions answered about my experiments. Feel free to do so. If you can't hear me and I'm just like mumbling, just I put in the chat. Can you hear me? Try this. Connect to my live stream, see if I can actually hear myself. All right, seems like I got audio. Okay, good. Yeah, my audio is working. Yeah, put something in the live chat. It's there. It's open. You can type anything in, ask me any questions or whatever about my experiments I've done. Just a lot of spectators, but nobody's asking any questions. I'll keep it open for a while. I'm here. If you guys got questions, please ask. I can answer them the best I can, but you'll have to use the live chat. So I've been using those PCO electric transducers for my water machine, and they seem to be working really good. Yeah, I got them all set up on the tank, so it's actually harmonizing that frequency, 528 hertz and 432 hertz. So I got an upper and the lower, and I got the transducers placed on the tank, and they're making that sound. It's like a vibration. It's making a tone, and that tone goes and resonates in the water. And now, because of sending it through the magnets, I neutralized the water with the magnets, and then I reprogrammed the water with natural frequency back into the water to make the water more in its natural state as it would be in nature. So, yeah, it seems to be working good. I've been using the water for the last week or so. But yeah. You can check out my videos. I got a few videos on my water machine. And those piezoelectric transducers, I've seen a couple of guys doing energy generation. You can look up online. There's one guy that I actually correspond with every now and then. I ask him questions. Kind of part of this message board where you actually have to get invited to be on the message board. And one of the guys is Norman Lutan, and he's been doing this stuff for about 30 years, probably longer, 40 years. And he worked on this device back in 1995 called the Mra Device, which uses a quartz crystal quartz crystal transducer. I guess it's what they use for creating frequencies. I believe his was using about 43 kilohertz, and he was doing high energy gains using that device in a small little step-up transformer that he attached to it. Tried to get a patent on it, and then the U.S. Patent Office seized it because it was real, and they said, well, we're going to give it to you. And then they said, well, we're not going to give it to you. And then they said, we're also going to put it in the drawer and you're never going to see it again. So to this day, it's stuck in the U.S. Patent Office, and they won't issue the patent for him, and they won't also release the patent to him. So the government's pretty much put a hold on his patent for the Mra device. So that's the type of stuff I'm going to be working with in the new year with the piezo transducers. And like I wanted to try it first with the water machine, and I got it working with the signal generator, and they do work. So if you're going to experiment, I recommend getting at least 27 millimeter diameter ones. They come really, really small, and they also come a little bit larger. You can get them all on Amazon. They're there. Just type in piezo transducers. They use them for like guitar pickups and stuff like that. So you can order those. I ordered a pack of 20, and it cost me like $19 Canadian. And you can experiment with those. And I think these ones here, I can put 30 volts DC into it. So the power comes out on the negative end, which is actually that copper plate that's on the back of the transducer. So the power would go in through the positive on the red wire. The black wire is usually attached to the copper ring on the outside. So the power would be going through there, either to a coil or a transformer or a high voltage capacitor, and then from there to ground. But it has to be pulsed, because you're going to have like a frequency going with it. So either you use a frequency generator, or you build yourself a 555 timer circuit, and that's adjustable, so you can adjust the frequency of that. You could use that, or you could use the big frequency generators that you have like for a bench top, which I also have, but I'm actually using that for the water machine right now. So yeah, I got the live chat there. Please ask me questions if you have any questions or whatever. I'll show you some of the gifts I got. So I got this for my cell phone now, so it's got a microphone, it's got the light there, and then I put my cell phone in there, and it's got the tripod now, so I can adjust everything and do better webcasting. And my wife also got me for Christmas, I got the actually, this is the camera I'm actually using for the webcast right now. I got the Ultra 4K action camera, so that's what I'm using right now for the webcast. So it's a pretty good camera. I got to get a micro SD card for it, probably tomorrow, I hope, if they have it. And so I got that to play with. Hey Curtis, how's it going? Thanks for starting the chat. If you have any questions, ask me. I'm here. It's kind of a Q&A, so you can pretty much ask me anything you guys want. What I'm doing, my experiments, it's up to you, really. So, yeah, I'm here. Just ask me questions. Everybody have a good Christmas? Good? Bad? Good? Cheesecake. I had some too. I actually had apple pie yesterday. That was really good. Yeah, cheesecake's always good. It's one of my favorite. Ooh, got a new hat. Good Christmas, yeah. It was very good. Felt better. Wasn't feeling good that last week. Just before Christmas, it was like 5 days. It just like felt like total garbage. And I got the cough after, and now the cough is pretty well gone, but it comes and goes. Yeah. So, what else can I show you? Yeah. Thanks, Molly. You guys have any questions about my experiments? Actually, hold on one sec. I can pull one of my boards out if you guys want to see a little better close up now that I'm using the 4K camera. Just bear with me for 1 second. So there's the device here. You guys can get a better close up on it. Now it's in the 4K. Well, I got it all set up there. And the wires here. It's for the light. So I'm trying to give you guys a good close up how it looks. Got the on-off switch. This is really good having this on-off switch now, so I don't have to always turn off my power supply. I can just flip this on and off, put one setting on my power supply, and then I don't have to touch it no more. And then this is that high-powered ion generator you get on Amazon. They're like $20-25, and yeah, I've been doing a lot of vitamin C over this holiday. A lot of vitamin C. Just a little better close up. So you can actually see it good. This 4K camera kicks ass. This is really good. Yeah, so I simplified everything on it. You get too complicated and then you get lost in it, and then you can't even follow your own wiring. So that's why I wanted to simplify this. It's easy to follow it, all the wiring. I'm going to be adding a lot more capacitors here, because capacitors, when it comes to an active power system, you got to have a lot of capacitors. Now, if you look at the old Don Smith devices, his capacitors were these giant honking, blocks, the real industrial size capacitors. And that's what you really need if you want to run this as an active system. But my goal is more or less to change this active system into more of a battery charging system. So I'll be adding the full wave bridge rectifier up in this area here. And then, excuse me, then I can start charging up capacitors again. And then I'm going to try hooking it up actually to a solar charge controller. And then from there, I can charge batteries in a good way, using the solar charge controller, because if you just do it straight into the battery, you take a risk of damaging the battery. But if you use the solar charge controllers, that sorts it out when it goes through the charge controller, and then it'll send the proper voltage to your batteries, especially if you're using lithium iron phosphate batteries. You want to charge them correctly. Some people say you could charge it any way you want, you won't damage them, but from what I've heard, that you need is the charge controller for the lithium iron phosphate batteries, um, because they can get damaged, even though that they have a controller that controls the charging sequence in it. I'll show you the battery that I've got. Hold on. Put this down here. So this is the battery I've got. I got this on Amazon as well. These are not the best ones on the market, but it's a lithium iron phosphate battery. They're dry cell. They're really, really light. Like compared to like a lead acid battery, these things are like a 16th of the weight. Like they're like nothing. Like I can hold it with one hand, no problem. It's also dry cell. There's no liquid electrolyte in it, so it's lithium iron phosphate battery. They call it LiPo 04 battery. This one actually has a voltmeter built on it, so right now it's at 13 volts, and it comes with a charger. I believe this one was about 120 bucks Canadian, so it's like $100 US or whatever. But they come from China, so it will take some time to get them in. I like using these because they're a good battery. They last a long time. They have a long life, just like almost like a capacitor. Like a lead acid battery cannot last as long as these guys. You can charge and discharge probably 100,000 times with this thing, and it'll still be running good. Where if you were to do that with any lead acid battery, like a car battery, they'll be dead. They just don't. You can't charge that amount of cycles with a lead acid battery, but lithium iron phosphate battery, they're like almost like a capacitor. They have huge amount of charge and discharge cycles. So yeah, that could be a useful for your project. So instead of spending a huge amount of money on the lead acid batteries, which can get pricey if you keep burning them out every 3 months, because you're going to be doing so much charging and discharging, you might want to consider getting one of these guys. Yeah, they are expensive, but at least you can get a lot more use out of these guys than you can with the lead acid. Lead acid ones, yeah, if you're doing your final testing and you want to test your system out, yeah, okay, use the lead acid. Or if you want to stay with these guys, hey, if you got the money, I don't know what your budget is, but these things are not cheap. But yeah, so it's a good choice of battery if you're going to do a lot of experimenting with charging and discharging. So yeah, they cost more, but you know what? It's worth it in the end, because you'll spend 6 times the amount on a regular lead acid battery, or all the other even lithium ion batteries. Lithium ion are not as good as these guys, because they have to be charged correctly, and they can overheat, they can explode. You could have all those problems with them. But this one here, if you're looking on Amazon, it's Fly 9-B, 12 volts, 72 watt hour. Yeah, this is a 72 watt hour battery. These are made for like electric bikes and those scooters and stuff like that. They can use these batteries here, so it's a good choice. What else can I show you? Questions, please. Shoot any question if you want. I'm trying to get a chat going here so I can stream for a while. It's a Q&A, so ask me anything, because sometimes it's hard to reply to everybody's comments. You don't realize how many emails I get every day, and the chats get pretty extensive too, when I start posting my videos. And we're doing good. Our channel's like over 1,100 subscribers now, so that's like awesome. So we're getting a lot more traffic. The last couple of weeks hasn't been really good for me because I got sick, and then you know how it is, just stuff happens, right? And yeah, right now I got 1,120 subscribers, so yeah, we're doing pretty good. And we're getting about 52,000 impressions on the site. that's like views over Facebook and all the different social media sites. So I got about 52,000 views from other platforms and everything. How big of a system do you need to power a house? The average household will use about 7 kilowatt hours. So you're looking at least 7 kilowatts. So to put that into perspective, you would need about, I would say, I wouldn't go less than 6 car batteries hooked up in parallel. So, or not in parallel, sorry, in series. You need 6 car batteries that are at least 120 watt hour or better. And then depending on what you're going to be powering with it, like if you're going to be powering, say, like an electric stove, stuff like that, or an air AC unit, that's going to draw a huge amount of amperage. And that's going to kill the batteries pretty fast. So if you're going to have an off-the-grid home, I would use it for more or less lower power devices, TVs, VCRs, what else? Your internet, all your lighting in the house, microwave oven, you can run off it, no problem. Vacuum spark gaps, yeah, I've been looking into that. I'm thinking about building my own vacuum spark gap. But anyways, to go back to the house thing here, you need quite a few batteries. Now, it depends on how much recovery power that you have, if you're using a solar panel or an over unity charging system like I'm developing. So the way I work at it, you would need at least 72 hours of standby power. If you can sustain 72 hours with that power bank. Some people go with minimum 8 batteries for a system. And it all depends how much power you really use. So you have to monitor. You would get a good solar charge control unit that would tell you how many watt hours you're using. And you would have to calculate it. Everybody's situation is different. How much are they actually using? How many? But they're saying the average household uses about 7 kilowatt hours per day. So the Tesla tower on the roof, yeah, it's big bucks. If you got the money and you're willing to spend that amount of money on solar panels, yeah, it's good if you got the money. But there's so many other alternatives. There's so much technology out there now, so you can convert your house to a off the grid system now. See, if I were going to set up a house like that, the electricity would be only for microwave, lighting, maybe your dryer, all your lower power devices. Even microwave is fine. But if you're going to get into a stove or AC unit, I would have them separated. You could get some really good gas stoves. They even make propane stoves. I would get something that's off that system. You probably could, or you can buy those little tabletop ones that have a couple of grills on it. They're like 1,500 or 2,000 watts. Just see some. When you make your over unity system. I'm working on the system now. These systems take a long time to build, especially if you're working with a new concept. When I was working on the end machine, that took me a year to get it to where I wanted it. And that's kind of an unfinished project right now. It's kind of on hold because I'm working with some other technology that's going to kind of take that end machine maybe to another level of power. Because right now it can create a lot of amperage, but the voltage is not there. So I've had a few tips and I've had a couple of leads on how to make that a lot more powerful. So, but I'm working on this system right now with the spark gap generator. Show everybody again. This is set here. You got the coil and you got the spark gap. So I'll try to get this all into here. So this is the high voltage generator. You get it on Amazon. Goes through the block here. You got two capacitors, 11 kVA. Goes through the first spark gap here, and then comes around, comes out here, and then it goes to a bigger capacitor bank. These are 15 kVA ceramic capacitors, and then from there it goes to the coil, and then it comes up the secondary winding of the coil, and then goes to your load. Now, either if it's going to be an active power system or if it's going to be a charging system. So if it's going to be a charging system, you're going to want to send this high voltage into a full wave bridge rectifier and capacitor bank. And then from there, it can go to a charging controller, which charges batteries like through your lithium iron phosphate battery or your lead acid or whatever you choose. So yeah, so it's going to take me a while to finish and develop this the way I want it. And then after that, then I'm going to work on the flywheel generator, which is going to be kind of the first stage of the system. So I've got a circuit that some guys have experimented in the past on how to create an over unity flywheel generator. It's actually a pretty interesting circuit. I've never seen it before, and there's like next to no literature on the web. It was kind of like finding a needle in a haystack when I found this. And they're claiming that their devices were hitting about 300% over unity, according to their calculations. And yeah, so that's coming in the new year. That's going to be another build altogether. And that's going to be combined with this system, and then together it runs as a full unit. And yeah, well, that's coming up. So I got some Christmas gifts. I don't know if everybody's seen it. My wife got me the camera we're actually using right now for live stream, 4K Ultra HD cam. So now I can go on the road with it. What else? I also got we got this. Now I can put my cell phone here. It's got a light, and it's got also a microphone, so I can do all my webcasting and stuff. Yeah, flywheels are definitely really good for storing energy because I'll tell you right now, it is a technology that we should have been working on a long time ago. And I would take a flywheel generating storage system over any solar panel any day of the week, by far. So yeah, definitely the flywheel generator is a far superior system than any solar panel. Back in the day when they were using it in Sweden in their buses, they were using these things, but the technology wasn't there. They had problems with bearings and more mechanical wear and tear, so they kind of got away from it. But it was a system that did work. So now our technology is way better. We got way better bearings, ways of balancing, and just the technology is better. It's right up there now. So to use that flywheel generator is far superior than any solar panel. And if you go into physics, any moving body in motion tends to stay in motion. So a perfect example is our planet. It's been spinning for 4 billion years. It is slowing down very slowly, but it's been spinning for 4 billion years. So there you go. There's a perpetual motion device right there, the planet. And if you can build a really good functional flywheel system, hey, you can power stuff for a long time. So coming in New York State, developing tech for electrical storage at windmills. Went bankrupt about 10 years ago. Yeah, well, they come and go because they don't get the coverage that they should. And, everybody's still relying on oil, right? So solar $300 for each battery. Yeah, that's why you use the lithium iron phosphate batteries. If you use regular batteries and you spend $400 or $500 on lead acid batteries, it's a waste of money. You have to go with the lithium iron phosphate batteries. Like a car size version of this battery is about $600, $700. Yeah, it's a lot of money, but you'll have many recharge cycles with these batteries, where far superior than a lead acid battery. So yeah, your initial cost for batteries, say you use 5 or 6 of them, it might run you about $3,000. $3,000 just for the batteries. Fine, but at least you know that this $3,000 investment is going to last you 30 years, because that's the amount of recycle time that you have with a lithium iron phosphate battery. It's almost as good as your capacitors. They last forever. So you can recharge that thing time and time again, and you'll never lose anything. They should not catching on according to plan. Well, wait and see. I'll tell you right now, this oil thing's not going to last forever. Piping all the oil out of the ground is coming to an end, and they got to do it from the ocean. And to do that from the ocean, the costs are astronomical, and that's why our gas keeps going up and up and up. It's $1.40 a liter here in Canada, which is probably what, $3 or $4 a gallon in the US. It's getting expensive there too. Like up into California, gas and food are really expensive in California. Even been to New York City, same deal. Like I go to New York City and I buy a Tim Hortons coffee in downtown New York City. It costs me like almost $4, and that's like buying a Starbucks here in Canada right now. It's like $4 for a coffee. It's costs, right? With the oil, it's costs, and the costs keep rising and rising because the supply and demand keeps rising and rising, but they're not mining enough out of the ground to keep up with demand, and it can only last for so long. Yeah, flywheels are definitely a great potential. That's why I'm going to work on mine this year, because they're very little maintenance other than the bearings, and as long as you got a good engineered housing, some people even put them in a vacuum chamber. All depends how far you want to go with it, right? Yeah, see, like the petroleum, what they should have been doing is using the petroleum for like plastics, stuff like that. That's what petroleum should be used for, not for fueling cars and stuff like that. I had an idea years ago when I was a lot younger of actually adding a flywheel generator inside a car. And guess what they're doing in F1 right now? They're using flywheels. Gee, I wonder why. So some of the ideas I had way back 20-25 years ago, they're actually using now in F1, using a flywheel, spinning flywheel inside the F1 racing cars to get them greater acceleration out of the corner and stuff like that. So yeah, the flywheel thing is something that should have been really embraced, and they never did. There are a few companies out there that are working on these power grids using the flywheels. So maybe I Russians. Yeah, vacuum is key. Yeah. Yeah. Here's the battery if you're interested. It's on Amazon. It's not the best battery out there, but it is a lithium iron phosphate battery. Life PO4 battery. And it comes actually with a voltmeter on it. So this one's running at about 13 volts right now. So yeah, I've been experimenting using it for a little while and had no problems with it whatsoever. It comes with a charger, and it's got the charge controller actually built in it. So the cells inside actually charge evenly, because it's very similar to a capacitor type system. So yeah, you can look these up. This one's a 72 watt hour battery. And the code for the battery is Fly9-B, 12 volt, 72 watt hour. Yeah, so you can look into those batteries. Yeah, they're building flywheels with Kevlar. Yeah, because they're spinning at ridiculous velocities. But I think where some of those guys out there that I was watching, they're using very, very small diameter wheels. You actually have to go to a larger diameter wheel, which means you don't have to spin the wheel as fast. Plus, you're going to have that kinetic energy stored in that. So it's more of a weight and diameter. Now, also the size of the diameter of the shaft used, the smaller that diameter, the easier and the longer, the less friction it's going to have pivoting on a point. So, yeah, that's what you want to do. And that's what I'm going to be doing. The wheel I'm going to use is going to be about 12 inches or better, probably at least 12 inches in diameter. And it's going to weigh at least 10 to 15 pounds, maybe even more. I have to look. There's some wheels out there I've been looking at, and yeah, like I'm not going to be spinning wheels at 100,000 RPMs. I just don't have the resources to do that. But I can make a system that does charge and does keep running on its own. We have to focus on current frequency as a factor of resonance to improve conductivity. Yeah, frequency and resonance of the coil. Like if you're working with coils and you got two coils and you want them to harmonize together, they got to be like a tuning fork. So if you ring one, the other one's going to ring two. And they have to be the same windings, same gauge wire, the same diameter, the same length of the coil. You have to methodically make them exactly the same, identical in every way, shape, and form. And also do an ohms reading test on each so you can kind of compare between the two. Because regardless of how accurate you make those two together, there will be a slight difference in resonance. So you would have to use a trim pot or a variable resistor on it. I've seen Don Smith actually used trim pots to actually adjust that fine tune so you can get the two coils within resonance. Second you get them into resonance, that transfer of power is instantaneous. There's no, you're not putting any strain on the dipole whatsoever. You're feeding it wirelessly through the air, through the dielectric field, and yeah, it works fantastic if you get that just right. Yeah, flywheels can be dangerous if they lose their balance, and if you have bearing failure, yeah, it can be catastrophic. But like I said, my wheels aren't going to be spinning at 100,000 RPM. They're not. I just don't have the facility to actually build something like that. I know how to do it, but I don't have the facility or the funds to actually manufacture something like that. And I work for an aerospace company, and I know the cost to make something like that are enormous. To make a wheel that goes 100,000 RPM, yeah, I'm looking like tens of thousands of dollars. And yeah, so your output magnet motors. What is my output on my magnet motors? My pulse motor, if I get it within resonance, if I'm using the right resistive load on it, because the resistive load will determine how much power your back EMF spike is going to go. So if I turn it on and there's no load on it, I'll probably get maybe about 90 to 100 volts DC pulsed. But the second I put a resistive load, if I put a 5.5 watt LED bulb, the resistance on it will get the high voltage spikes up to about 160 volts DC pulsed. So the resistive load will really determine on how high your back EMF spikes coming off your motor coil is going to be. So you have to play around with those numbers. That's where a lot of people fail in their pulse motors, because there is a threshold if you're under, you're not going to get the voltage you want. And then if you go above that, you're going to kill off your dipole and you won't get the high voltage spikes that you want. It's like a tuning fork. And you put any resistance on that tuning fork, the tone or the frequency is going to go down. That's when you lose your power. So, kind of limited, I think, some power source so far. Yeah, like I've made pulse motors with friggin' lawnmower wheels. So you don't have to use 3D printed stuff like I've done. You can go and get a good lawnmower wheel that has a good bearing on it, and then buy a set of bearings off of Amazon so they can sit on and spin. And hey, I've done it with lawnmower wheels, and they work. So they actually work pretty good. Yeah, well, I've been doing it for a while. Like I started in the mid 2000s with the HHO stuff. That's where I kind of got my feet wet in this over Unity stuff. And I had a friend years later said, "Yeah, I was working on that too." And he goes, "Yeah, I went for an emissions test and everything came out 0." I'm like, "What?" He goes, "Yeah." He had one of those Austin Minis, or sorry, no, he had a Mazda with the rotary engine. The old Mazda RX-7s with the rotary engine, and he hooked up one of those hydrogen generators and he took it for an emissions test. They put it on the dyno, and after he put it on the dyno, he got the reading back, and all the O2 and all the carbon dioxide and all that stuff was basically almost at 0. So not only that it made his car more efficient, it also made his car run way cleaner. So, as far as I know, there's a couple guys out there that are making these HHO generators for the diesel engines, and that actually helps the diesel engine become a lot cleaner. So, what else we got here? Yeah, so after that, sorry, what do you think about the complete magnet-driven motor? Oh, the magnet-driven motor. Ooh, I've never really dabbled with that. That takes a lot of engineering to get it done right, because every single magnet has to be at a certain angle. If you got the time and you have the engineering programs to actually design something like that, it would take a long time because you're dealing with so many magnets. And if they're not in the right alignment, you will not get that spin action happening. It takes a lot of engineering to make those, believe it or not. Hey, Aaron, how's it going? Just testing out my new cam. Got a 4K Ultra HD. My wife got that for Christmas for me, so now I'm actually using it right now. I got it on the tripod, and I also got this other stand here. It's got the microphone, light, all that, so now I can do my casting through that. And what else we got here? What's that? Xbox One Kinetics works well with, especially with the 3D modeling for printing. Hey everybody, thanks for logging in. Angle and timing for backyard tinker. Oh yeah, and the pulse motors. If you're working with a pulse motor, you need its the reed switch isolated from the rest of the motor. Because if you're not isolating your reed switch from a pulse motor, that reed switch will eventually burn out. especially if you're using the vacuum tube ones. Yeah, they'll burn out. So that has to be a separate isolation away from the actual power system. And you have to use a separate little battery, a 9-volt battery or whatever, to run your switch and the reed switch. So isolate it. I've blown up many reed switches. Trust me. So now every single pulse motor I make is totally isolated from the rest of the system. 1,000-watt vertical wind generator. Yeah, wind generators are good too, as long as you got the wind. I'm totally for wind power. Wind power is good. 1,000-watt, that's pretty powerful, providing you got enough wind there to sustain, a windmill running all the time. Like even solar too, depending on what state you live in the U.S., you got a lot of sunlight there, so solar panels are worth it. They're coming down in price, and there's so many choices now. The technology is out there, right? So freezed. My screen's kind of froze on me. I'm having issues with this computer. It's like 6 years old, so she's kind of getting a little slow.
Buddy?
Yeah, my computer pooched on me. See if it recovers. I don't know if it's working or not working. Let's see. I'll have to log in. My screen is kind of frozen on me. Is it working? It is working. Okay. Cool. It is working. I'm surprised. Yeah, my screen's kind of frozen, so what I'm going to do is I'm going to end the stream and maybe do another one later. Because I can't really chat with anybody on this. I can't see updated chat board going here. My computer's kind of crapped out on me. That's another thing I need, a new computer. Well, this thing's 6 years old, so I can't really say too much. I get 6 years out of a laptop here pretty good. So, move that back. All right, so what I'm going to do is I'm going to end the stream, and then I'm going to come back and maybe start again just to kind of clear things up, because my computer's kind of a hurt unit. I'll be back. I'll be doing more videos this week. I'll be doing some maybe live stream builds and stuff what I'm working on. Give me a thumbs up if you liked it. And if you haven't been a subscriber yet, do that. Subscribe to the channel. And also, there are links in my other videos for my Patreon. So if you want to become part of my Patreon, you could do so as well. I'll be doing a lot of stuff in the new year. There's a lot of great things coming. And I'm excited about what's going to come up in the next year. So we're going to see some cool stuff. I'm just getting warmed up, and all right. So thanks everybody for showing up, and we'll do another stream very, very soon. Take care. Oh, those computers just unbelievable.
Sushi. Are you done?
Yeah, I'm off now.